Hello friends, welcome to the third session of Directional Transient Ground Fault. In these sessions, we are discussing the sensitive ground fault, and in a special case, we are discussing on Directional Transient Ground Fault. We are going to understand how really the relay operates, detects, and picks up or operate on transient ground fault. On the first session, we discussed how the relay operates in normal condition during the fault and just immediately after happening of the fault. In the first session, we discussed about the block A and how the exact time of happening of transient ground fault or occurring the transient ground fault is detected, and that is the time of zero, how this time of zero is detected. And on next session we discussed about this SR latch, and we discussed about the direction determination block and how this block operates, which we call this as a block B. And we discussed how this block works, and on a negative value of zero sequence power, the active part of zero sequence power, when it is negative, then the fault is in forward direction. For more discussions and more details, you can refer to the second session for understanding of zero sequence power calculation. In this session, we are discussing when suppose the direction determination block determined the direction, then the signal goes into this part of the switch. Suppose we call it as a switch, but internally inside of relay it is not really switch. Some of electronic components are used, and this switch is operated based on the block. We call this as a block C, and this block is the stabilization against CB opening. Let's understand how this block works, but before that let's know that just immediately after the S terminal of SR latch is on, then the output Q is on, then output Q gives the signal to one another block, that is the time delay block, that is internally pre-programmed. This is already programmed inside of the relay, and 100 milliseconds it gives a delay. Then the signal is supplied to the stabilization block. Let's understand how this block works and why we use this block C, that is a stabilization block. Suppose that here we have one line AB, and it is continued to another line of BC. The second in from the B to C. Here, for example, we have a circuit breaker. We call this circuit breaker 2, and on our main line, which we are installing, we are activating the directional transient ground fault in this session AB. We call this circuit breaker CB1. Now sometimes this CB2 gets off. It means opening of the circuit breaker 2. During the opening of the circuit breaker 2, the relay which we already installed in this portion for the section AB, this relay thinks that there is a ground fault, or there is a sensitive fault, because this CT is connected to, and the PT is also connected to this relay, and due to opening of the circuit breaker 2, this zero sequence voltage, which is detected by from the PT, This zero sequence voltage, we already discussed that maybe it has an operational value of 1.2 volts. It is an operational value, and this may change due to opening of this circuit breaker. If the load in the station BC is low, then it may change to 2 point something volt. Then maybe we have a threshold value of 3. It means when the zero sequence voltage gets greater or equal to 3 volt, then it operates. So during this marginal change, very minor change from the operational value of zero sequence voltage to 2 volt, then the relay may not operate, and relay may not think that there is a transient ground fault on the system. But maybe suppose if the loading of station BC is very high, maybe it is a long transmission line or it's a really heavily loaded feeder, then this threshold value, maybe from the operational value, it may change from 1.2 to maybe 3.5, 3 point something. Then it is greater than threshold value. In this condition, the relay will misunderstand and the relay will think that there is a transient ground fault and there is a ground fault on the system. Then in this condition, what can we do is going to another method to detect that there is not any ground fault on the system and it is a CB opening. That is the positive sequence current on the system. The relay should do understanding and analyzing the positive sequence current just before T0, it means at the time of happening of the fault, and it should compare it with the I1, it means the positive sequence current, just after the happening of the fault, before happening of the fault and after happening of the fault, analyzing of the positive sequence current. If this CB is opened, then there is a huge change on the positive sequence current of the system. Then with comparing of these two values, the relay will understand that, okay, it is just because T1, I1, it means positive sequence current after T0 is almost 0, and before that there is no change, so the relay will understand that, okay, there is no fault, there is a happening of CB opening or second circuit breaker opening of the system. This is all what the block C or stabilizing block does. The stabilizing block, when there is any change on I1, means the positive sequence current, just before T0 and after T0, a huge change is there, then the relay will understand that there is no ground fault and it is just CB opening, so it sends yes, and the reset signal is generated. This reset signal resets these two registers, these two SR lights, these two SR lights, and these SR lights are resetted and the pickup signal is not generated. And the furthermore discussions about what really happens, this reset signal is also generated here, and these reset signals and the pickup process and the threshold process we will discuss in the next session. But what happens if there is no major change on the positive sequence current just before the T0 and after T0, then the block C generates a signal on the no terminal, which just turns on this switch, and this switch connects the signal from the direction determination, which is already generated. This signal is supplied to comparison block with predefined direction that this block already is defined that it should operate on the forward direction or not. Then this signal is supplied to another AND block, and then another portion of AND block is from the threshold values from which we generate here, these threshold blocks. Then it comes, which we will discuss in the next session. Then the pickup signal is generated.